Four astronomers stare at their computer screens in disbelief. The data streaming in from the James Webb Space Telescope shows something that shouldn't exist. A galaxy blazing with light from when the universe was barely 280 million years old, just 2% of its current age. But that's not what makes their hands tremble. This galaxy is shining 100 times brighter than every theoretical model predicted. Lead researcher Rohan Naidu from MIT's Kavli Institute leans back in his chair and mutters what every scientist in the room is thinking. The early universe looks nothing like what we predicted. On January 28, 2026, the discovery of galaxy MOM-Z14 didn't just push back the boundaries of observable space. It shattered our fundamental understanding of cosmic history. To grasp what makes this discovery so revolutionary, you need to understand the journey this light took to reach us. When photons left MOM-Z14, they began a voyage across expanding space that would last 13.5 billion years, roughly 98% of the universe's entire existence. As space itself stretched during this cosmic odyssey, those photons got pulled along with it, their wavelength stretching like taffy, shifting from visible light into the infrared spectrum. This phenomenon, called cosmological redshift, acts like a cosmic timestamp. MOM-Z14's redshift value of 14.44 means we're witnessing this galaxy as it appeared when the cosmos was still in its infancy, before the first stars had even finished clearing the thick fog of hydrogen that filled primordial space. But here's where the mystery deepens. This ancient galaxy isn't behaving like a cosmic toddler. It's radiating with the intensity of a fully mature system. Before Webb launched, astronomers had predictions. Computer simulations running on the world's most powerful supercomputers modeled how the first galaxies should form. They painted a picture of small, faint systems slowly coalescing from clouds of hydrogen and helium, gradually building up mass over hundreds of millions of years. The early universe, according to these models, should be filled with dim, struggling proto-galaxies, cosmic kindergartners, if you will. MOM-Z14 obliterates that expectation. This galaxy is 100 times more luminous than it has any right to be. It's as if evolution fast-forwarded, skipping straight from single cells to complex organisms in the cosmic blink of an eye. But here's where it gets even stranger. MOM-Z14 isn't alone in breaking the rules. Webb has now uncovered an entire population of these unexpectedly brilliant early galaxies. When Pascal Oesch from the University of Geneva and his team first spotted similar objects in Webb's data, they assumed measurement errors. We can estimate the distance of galaxies from images, Oesch explains, but it's really important to follow up and confirm with more detailed spectroscopy so that we know exactly what we are seeing. That's where Webb's NIRSpec instrument becomes crucial. This near-infrared spectrograph doesn't just take pictures, it dissects light into its component wavelengths, creating a cosmic fingerprint that reveals a galaxy's true distance, composition, and physical state. The spectroscopic analysis revealed something unexpected in MOM-Z14's light signature. The galaxy shows unusual enrichment in nitrogen, an element that shouldn't be abundant so early in cosmic history. Nitrogen forms inside massive stars through nuclear fusion, requiring multiple generations of stellar life and death to accumulate in significant quantities. Yet here it is, somehow present in substantial amounts when the universe was barely out of diapers. We can take a page from archaeology, Naidu notes, and look at ancient stars in our own galaxy like fossils from the early universe, except in astronomy we are lucky enough to have Webb seeing so far that we also have direct information about galaxies during that time. It turns out we are seeing some of the same features, like this unusual nitrogen enrichment. This discovery forces a fundamental reckoning. Either our understanding of how galaxies form is incomplete, or the early universe operated under different physical rules than we thought. The massive star formation required to produce MOM-Z14's brightness would need gas supplies and gravitational dynamics that current models can't explain. Some researchers propose that dark matter, the invisible scaffolding that shapes cosmic structure, clumped together far more efficiently in the early universe than simulations predict. Others suggest that the first stars were fundamentally different from modern ones, perhaps forming as supermassive behemoths that lived fast and died young, pumping out extraordinary amounts of light and heavy elements in compressed timescales. What makes this moment particularly thrilling is what it reveals about Webb's capabilities. The telescope's predecessor, Hubble, had already hinted at weirdness by discovering galaxy GN-Z11 at 400 million years after the Big Bang. But Hubble was working at the edge of its abilities, squinting through cosmic distance. Webb operates in infrared wavelengths specifically designed to catch this ancient red-shifted light. It's like finally putting on the right pair of glasses after years of blurry vision. Yeojia Lee, a graduate student at Pennsylvania State University working on the research team, captures the excitement. It's an incredibly exciting time, with Webb revealing the early universe like never before and showing us how much there still is to discover. The implications ripple outward. MOMZ-14 is giving astronomers direct observational evidence of a critical period called the epoch of reionization. During the universe's first few 100 million years, space was opaque, filled with neutral hydrogen that absorbed light like fog, obscures a street lamp. The first galaxies had to produce enough energetic radiation to break apart these hydrogen atoms, ionizing the gas and allowing light to travel freely through space. MOMZ-14 appears to be one of these cosmic pioneers, actively clearing the fog. Scientists can see this process in action through the galaxy's spectral signature, watching history unfold in electromagnetic wavelengths. The discovery also represents a methodological triumph. The research team didn't just stumble upon MOMZ-14. They systematically combed through Webb's archive of deep field surveys, images that capture thousands of galaxies in single exposures. Out of this cosmic haystack, they identified candidates based on their color and brightness, then followed up with time-intensive spectroscopy to confirm distances. It's detective work on a universal scale, and Webb has only been collecting data for a few years. The telescope's primary mission is planned to last a decade, potentially longer if its systems remain healthy. We're witnessing the opening act of a scientific revolution. So what happens next? Astronomers are already planning follow-up observations. They want to study MOMZ-14 in even greater detail, mapping its structure, measuring its stellar populations, and understanding the mechanisms driving its extraordinary luminosity. They're also hunting for more galaxies from this era, building a statistical sample that can test different formation theories. And they're looking even further back, pushing toward the cosmic dawn when the very first stars ignited. Each discovery reshapes the narrative, but MOMZ-14 represents something profound, concrete proof that the universe's opening chapters were far more dramatic, complex, and mysterious than our best minds imagined. The philosophical weight of this discovery shouldn't be overlooked. We're looking at photons that began their journey when the universe was younger than a human lifespan, carrying information across cosmic expanses that dwarf human comprehension. This light traveled through space for longer than Earth has existed, longer than our solar system has existed, arriving at our telescopes at precisely the moment when technology advanced enough to decode its secrets. And what those secrets reveal is humbling. The universe doesn't care about our models, our predictions, our carefully constructed theories. It simply is. Stranger, more violent, more magnificent than we dared conceive. What do you think this means for our place in the cosmos? If galaxies were forming and evolving this rapidly when the universe was barely born, does that change your perspective on how common or rare complex structures and maybe life might be across space and time? The comments are open, and I genuinely want to hear your thoughts. Whether you're a seasoned astrophysicist or someone just fascinated by the night sky, this discovery belongs to all of us. It's a reminder that we live in an era where we can actually witness cosmic history, where questions that philosophers could only ponder are now being answered by machines floating 1 million kilometers from Earth, staring into the deepest darkness to bring back light.